With their perpetual smiles and feathery gills, axolotls have become one of the internet's most beloved creatures. Today, millions can be found in laboratories and home aquariums worldwide. In fact, even you watching this might have one as a pet. But despite this, in the wild the axolotl is on the brink of extinction. Between 1998 and 2008, the population density crashed from 6,000 per square kilometer to just 100. And in 2013, scientists spent 4 months searching and found exactly 0. Nobody knows how many are left now, but the number is no doubt shockingly low. So how did we get here? How did one of the most famous amphibians become one of the most endangered? What even are axolotls? And what makes saving them so complicated? Most adult axolotls range from 15 to 45 centimeters long, about 23 on average. But what makes them unique is that they almost entirely possess features common in salamander larvae, such as their external gills and caudal fin, which in pretty much every other species of salamander are lost during the transition to adulthood. The gills disappear, the fin shrinks, and most importantly the animal moves onto land. But axolotls skip that whole process. They reach maturity while still keeping their juvenile form, a phenomenon known as neoteny. Basically, axolotls are kids who never grow up. Their underdeveloped limbs and long and thin fingers make it impossible for axolotls to maneuver on land. And whilst other salamanders only develop teeth during metamorphosis, axolotls actually have vestigial teeth even in their juvenile form. However, these teeth are basically useless since the axolotl primarily feeds through suction. They just open their mouths, supported by their wide heads, and suddenly, dinner. In the wild, axolotls are brown with speckles, helping them to blend into the murky lake bottom. The pink and black forms that are common as pets came from decades of selective breeding in laboratories, which unfortunately means these captive individuals would never survive in the wild, as they'd be spotted immediately by predators. But of all the axolotl's features, there's one that makes it truly extraordinary. Axolotls can regenerate themselves. And not just limbs, which is impressive alone, but heart and eye tissue. Such an ability is unheard of in the animal kingdom. Cut off a leg and within weeks, a perfect new one grows in its place, complete with bones, muscles, nerves, and skin. They are probably able to do this due to their neoteny, as they retain the ability to grow quickly that most animals lose during adolescence. However, if certain hormones are administered in a lab, the axolotl will metamorphose normally. They will turn into a terrestrial form which closely resembles tiger salamanders. So where exactly do these bizarre creatures come from? Well, the axolotl is native to the Valley of Mexico, and you won't find axolotls anywhere else on Earth. However, the landscape remains a far cry from what it once was. The valley was once filled by Mega Lake Texcoco, a massive water body over twice the size of New York City. The Aztecs and various other city-states made this their capital in times long ago, and drained small amounts of it. Over the centuries, the population exploded. The former lake is now home to 21 million people, and it's better known as Mexico City. The lake was first drained for agriculture, though the axolotl survived in the extensive network of canals and reservoirs. However, these canals were gradually paved over with concrete and houses, destroying almost all of the suitable habitat. By the time scientists started paying attention to the rare creatures, only 3 sublakes remained: Zumpango, Xochimilco, and Chalco. But only the last 2 actually had any axolotls. And Lake Chalco was in a bad state with the water level fluctuating. This left Xochimilco as the last refuge. In the modern day, this lake is largely made up of canals, which fortunately are deep and vegetated enough to create a suitable habitat. Here in the murky waters, they prey upon mollusks, insects, and worms, whom they wait to ambush on the lake bottom. However, even with a sanctuary of their own, axolotls continue to decline at an alarming rate. The first population survey came in 1998. Scientists estimated that at the time, each square kilometer was home to an astounding 6,000 axolotls. The next survey, just 5 years later, showed a devastating decline to just 1,000 per square kilometer. And then in 2008, this figure dropped to just 100. A decline of 90% in just 5 years. But the most shocking result came in 2013. During a 4-month search in the wetlands of Xochimilco, scientists didn't find a single axolotl. Fortunately, a month later on a different expedition, 2 were finally spotted. This rarity is because axolotls are naturally hard creatures to find. The water is dark, the vegetation is dense, and they have a low activity lifestyle. In fact, they just sit there for the most part. This makes it impossible to get an accurate population estimate. However, we can know for sure that a few still remain. eDNA tests continue to show positive results in many canals. But it's very possible that the total population is in the double digits. In fact, wild axolotls haven't been seen by humans in years. So what on earth caused such a catastrophic decline? How did we go from 6,000 per square kilometer to almost nothing in just a decade? Well, the first reason is water quality. By the 1990s, Lake Xochimilco already had poor water quality, with a low nitrogen to phosphorus ratio and large amounts of chlorophyll A. Both are indicators of low oxygen levels, not good for axolotls who breathe through those external gills. And since then, things have gotten far worse. This is a direct result of the surrounding agriculture and aquaculture. Agriculture pollutes the water through pesticides, livestock waste, and sewage, whilst aquaculture operations pump large amounts of untreated wastewater to maintain the water level. As amphibians, they absorb lots of harmful chemicals through their skin, and it's reasonable to assume that this has killed many axolotls. Especially as lab studies have shown that pesticides massively increase mortality of their embryos, and cause birth defects in those that survive. However, the threat of pollution is minor compared to the next threat, invasive species. A long time ago, invasive fish arrived in Lake Xochimilco, specifically the Nile tilapia and the common carp. These species do two things that are catastrophic for axolotls. Firstly, they eat them whole, especially the young, and secondly, they compete with them for food. To avoid predation, the axolotls reduce their activity levels, spending more time in hiding. This caused fewer axolotls to run into each other, and thus reproduce. All of these factors combine to create the perfect storm for extinction. And with such a small population remaining, another problem has emerged. Studies in the 2000s found extremely low rates of gene flow in wild axolotls, likely the result of several bottleneck events in their history, as well as recent inbreeding. High rates of inbreeding lead to massively decreased fitness on a population-wide scale. Compared to 30 years ago, today's axolotls are more susceptible to disease, have more developmental problems, and are less able to adapt to the changing conditions. But it gets worse, the captive population might not be able to save them either. Captive individuals are largely derived from a small number of individuals caught in the wild in the 1960s. They've been raised in captivity for decades, and they're incredibly inbred. This means that they have far higher rates of deformities, even more so than the wild individuals. But even if they weren't, there is another problem. Studies have shown that the captive population contains a significant amount of DNA from tiger salamanders, likely the result of accidental hybridization in labs, which means that they are no longer pure axolotls. Then there is a problem with camouflage. Most captive axolotls are bright pink or in some cases black. In the wild, axolotls depend on their brown speckled camouflage to avoid being seen by predators. If one of these bright pink axolotls was released into the wild, it likely wouldn't survive more than a few days before being caught by an egret. It's also possible that captive bred individuals lack awareness of predators. Having been raised in safe aquariums with no threats, they might not even try to hide when a predator approaches. Because of this and failure to prevent their demise in the wild, scientists have turned to a different strategy. In 2021, the University of Mexico had built up a population of 100 axolotls descended from wild individuals. Not the captive inbred stock, but a population with more genetic diversity. Due to the ongoing threats, plans are underway to create a semi-artificial wetland where they can be released. The success of this project is life or death for axolotls. If it fails, axolotls will go extinct within our lifetime. Although on the chance it succeeds, axolotls may narrowly avoid extinction. But axolotls aren't the only salamanders to stay in a neotenic form their entire lives. In fact, there are 3 other species that do the same thing, and they're often referred to as axolotls as well. However, just like their more famous cousin, each one of them is on the brink. Anderson's salamander lives in Lake Zacapu in the state of Michoacan. This body of water is only 33 hectares, and the species wasn't even discovered until 1984. Today, Anderson's salamander is perhaps as threatened as the axolotl itself. The threats are the same: invasive fish species and increasing urban development around the lake. But unlike Anderson's salamander, the Lake Pátzcuaro salamander, better known as the achoke, has been known since pre-Columbian times, when it was used as a source of food. But since then, an invasive water hyacinth has taken over much of the lake, releasing loads of toxic particles that harm the salamanders, which combined with the introduction of invasive fish has pushed them towards extinction. Only an estimated 100 remain in the wild, and without serious intervention, it's predicted that they will go extinct between 2040 and 2050. Despite their impending extinction, the Mexican government has failed to implement any measures to protect the species. Thankfully, conservationists have established 4 breeding colonies with a total of 400 individuals. Far to the east of these populations, in the state of Puebla, lives Taylor's salamander. Found only in Lake Achichica, it was first described in 1982. It's a small species, about half the length of the axolotl, and lives in a fairly saline and extremely alkaline environment. As water is extracted for irrigation, the habitat is becoming more and more saline, and the water level has decreased dramatically. But unlike the other species, there is not a single individual in captivity. If they disappear from the wild, they're gone forever. Thanks for watching. If you enjoyed this video, please consider subscribing, and I'll see you in the next video.